Today's objective is dividing fractions and mixed numbers. So it is much easier to change mixed numbers to improper fractions before we multiply or divide, so that's what we're going to do. You totally can multiply or divide with mixed numbers. It's just a lot more steps. It's like you're doing the distributive property with it. So I don't want to do extra work, so I'm going to have you change the mixed numbers to improper fractions. All right, dividing by a number is the same as multiplying by its reciprocal. So let's review what a reciprocal is. A reciprocal, what you multiply another number by to get 1, positive 1. Reciprocal is the same as multiplicative inverse. Multiplicative inverse is larger vocabulary, but we've been doing some properties and we've done the additive inverse, but we haven't, and I think we did do the multiplicative inverse. It's the same as the reciprocal. Okay, those are the big words. So, if I have 2/3, what do I need to multiply it by to get 1? Well, it's the number flipped upside down. The multiplicative, so we're multiplying it, and it's the inverse, so it's flipped upside down. So 2/3, the reciprocal is 3/2, and that becomes 1 because we can simplify. 3 goes into itself once, 2 goes into itself once, 1 times 1 over 1 times 1 is 1. -4/5. Now if you have a negative number, the reciprocal is also negative. So this would be -5/4 because negative times negative is positive, and then once again the 5's cancel to 1 and the 4's cancel to 1, and 1 times 1 is 1. What if you have a mixed number? You need to change that to an improper fraction. So 2 1/3 becomes 2 times 3 plus 1, 7/3. So our reciprocal would just be 3/7. Some kids make a mistake because they just want to do the reciprocal of the fraction piece of the mixed number, but you need to make it improper. Okay? So I don't need to simplify. You can see this would be, if I didn't simplify, it'd be 21 over 21, which is 1. Now let's get back to the dividing by a number is the same as multiplying by its reciprocal. I put this in purple also. Let's say I said 8 divided by 2. 8 divided by 2 is 4. Okay? We were dividing. Well, what's the reciprocal of 2? 1/2. So if I said 8 times 1/2, I could, let's pretend I'm not simplifying, which I totally should do, which would be faster. But if I make my whole number into a fraction by putting it over 1, 8 times 1 is 8, 1 times 2 is 2, and once again we're doing 8 divided by 2, which is 4. So even though it looks like it's multiplying, when you multiply by a fraction, you get the same thing. So we're going to be using this concept, dividing by a number is the same as multiplying by its reciprocal with fractions because it makes our life easier. All right. Let's say I have the problem, -3/10 divided by 3/7. Once again, I need to determine if my answer is going to be positive or negative. So if I look at this, I see my answer is going to be negative. So when I rewrite the problem as a multiplication problem, I say -3/10 times, use the reciprocal, dividing by a number is the same as multiplying by its reciprocal, 7/3, and I'm going to put equals negative so I don't mess this whole thing up by forgetting that. Now, 3 and 3 can be simplified. 3 goes into itself once, so I just multiply straight across now. 1 times 7 and 10 times 1. And I already wrote my negative, so I won't mess that up. Let's say I have two mixed numbers. 4 and 1/6 divided by -1 and 2/3. I'm going to rewrite both of them as improper fractions. 6 times 4 is 24 plus 1 is 25/6. Still divided by 3 times 1 is 3 plus 2 is 5, -5/3. So don't take shortcuts and do the reciprocal at the same time because you might make a mistake, and don't make mistakes in this. Okay? There's time to do less work, but this is not one of them. So I'm going to copy down my first number, my first term. Dividing by a number is the same as multiplying by its reciprocal, -3/5. Negative times positive is negative, so I'm going to write equals negative. Now I see I can simplify several things. 25 and 5 have a common factor of 5. 5 goes into itself once, and 25 5 times. 6 and 3 have a common factor of 3. 3 goes into itself once. 3 goes into 6 twice. Now I can multiply straight across. 5 times 1 is 5. 2 times 1 is 2. But since my numbers, this is improper, but since my numbers were mixed to begin with, I need to change it back. So I say negative 2 goes into 5 twice with 1 left over. Okay? So this should be review. All right, here's a word problem. I have a gallon of punch. Well, a gallon is 128 ounces. And my cups hold 5 1/3 ounces without spilling. They say 6 ounces, but if I filled it to the top, it would spill. So I can put 5 1/3 ounces in without spilling. How many cups can I fill? So what this means is 128 divided by 5 1/3. Wow, it's a division problem. So I'm going to change my mixed number to an improper fraction. And then when I rewrite it as multiplication, I'll do 128 over 1 times 3/16. Now, this is one of those problems where we can use divisibility rules and see if 8 goes into this, or see if 16 goes into both. I know 16 goes into this, but I don't necessarily think you know. So let's just divide by, what do you want to divide by? How about 4? Because I can see that 4 goes into 12 and 4 goes into 8. So if I cancel and divide by 4, 16 divided by 4 is 4. And if I divide 128 by 4, I get 32. Oh, 4 and 32. I can reduce it more. You can reduce it more, okay? 4 goes into itself how many times? 1. How many times does 4 go into 32? 8. So now my problem is 8 times 3 over 1 times 1. What's 8 times 3? 24. But since this was a word problem, I need to have a word answer, so I'm going to write 24 cups. I don't need to write a complete sentence for this. It would if it was a word problem that I had to use let statements for, but since this is a word problem, I need to have a word with my answer. And that's it.